when you are told to find the nth derivative of a function, what you need to do is to differentiate that function a particular number of times, maybe find a fourth derivative, and observe a pattern from the first derivative leading to the fourth derivative, and see what pattern can you generalize to write the nth derivative. So the formula for the nth derivative will be in terms of n, where n is nth derivative. So let's begin by finding the first few derivatives of this function. So the function is f of x is equal to 2 raised to the power of x, and y is the same as f of x. So we'll replace f of x with y. So you have y is equal to 2 raised to the power of x. If you have y is equal to 2 raised to the power of x, you cannot differentiate just like this. So the first thing you need to do is to make sure this power comes down. And to bring that power down, we need the natural logarithm, the ln. So I'm going to take ln on both sides. So I'll have ln of y is equal to ln of 2 raised to the power of x. According to one of the rules of logarithm, if you have a power of the argument, that power goes behind the logarithm. So here you have ln of y is equal to x ln of 2. That's what you have. Now once we have this, we can differentiate each side with respect to each of the variables. So we differentiate this side with respect to y, and we differentiate this side with respect to x. So if we differentiate this side with respect to y, we have 1 over y prime is equal to, if we differentiate this side with respect to x, the derivative of x ln of x, ln of 2 is just ln of 2, because the derivative of x is 1 and ln of 2 is a constant. So if we cross multiply, we have y prime. So y prime is equal to y the ln of 2. This is y prime. But we know what is y. We know that y is 2 raised to the power of x, but y is 2 raised to the power of x. So we replace that value to find y prime in terms of x. So y prime will be equal to 2 raised to the power of x, which is y, the ln of 2. So this is the first derivative. We can go on again to find the second derivative. We know the first derivative is 2 raised to the power of x, the ln of 2. That's the derivative of 2 raised to the power of x. So the second derivative, meaning the derivative of y prime, will be y prime prime is equal to, if we differentiate 2 raised to the power of x, the derivative is 2 raised to the power of x, the ln of 2. So the derivative of this is 2 raised to the power of x, the ln of 2. And then we multiply that result, which is the derivative of this, by ln of 2. If we do that, we have y prime prime is equal to 2 raised to the power of x multiplied by the ln of 2 all squared. Great, because ln of 2 times ln of 2, you add the powers. We found the second derivative. Let's move on to the third derivative. The derivative of y prime prime is y prime prime prime. And y prime 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 will be equal to, in this case, we only have to differentiate 2 raised to the power of x. Again, the derivative of 2 raised to the power of x is 2 raised to the power of x, the ln of 2. So I replace this with 2 raised to the power of x, the ln of 2. So 2 raised to the power of x, the ln of 2, multiplied by the ln of 2 all squared, which is this. Now, I could continue finding the fourth derivative, fifth derivative, but it's like I'm seeing a pattern. For the first derivative, I have 2 raised to the power of x here, and I have 2 raised to the power of x raised to the power of 1. So, ln of x is raised to the power of 1. For the second derivative, I have the same 2 raised to the power of x, but I have ln of x raised to the power of 2. For the third derivative, I have the same 2 raised to the power of x. If I simplify this, I'll have 2 raised to the power of x times ln of x raised to the power of 3. If I find the fourth derivative, it will be 2 raised to the power of x, the ln of x raised to the power of 4, and so on. Therefore, I can conclude that the nth derivative of this function, since 2 raised to the power of x is constant in all of the derivatives, I'll have 2 raised to the power of x. Since the ln is constant in all the derivatives, I'll have the ln of x, ln of 2. And then raised to a power. For the first derivative, the power is 1. For the second derivative, the power is 2. For the third derivative, the power is 3. So the power of the ln of 2 will correspond to the derivative. So in this case, the nth derivative will be 2 raised to the power s, the n of 2 raised to the power of n. Or f to the n of x is equals to 2 raised to the power of x times n of 2 all to the power of n. So whatever number of derivative you want to find for 2 raised to the power of x, just replace n with that value. So example, if we want to find the 100th derivative of this function, it will be 100 derivative we have f to the power of 100 of x is equals to, so this f 100 of x, meaning the 100 derivative of f of x is equal to 2 raised to the power of x times n of 2 all raised to the power of 100. This will be the 100 derivative. You can find the 50 derivative, 40 derivative, and so on. Thank you very much for watching. I hope you subscribe to our YouTube channel and click the notification bell so you cannot miss future videos. Today we are going to be finding the area and the perimeter of a circle. So have you ever wondered how do you find the area of a circle? How do you find the perimeter of a circle? You stumble upon this video for a reason. So find the area and perimeter of a circle of radius 5 meters. Now the formula for finding the area of a circle is A is equals to pi r squared, and that of the perimeter is P is equals to 2 pi r. So remember, the area is the total space covered by that geometric figure, in this case a circle. So the total space covered by that circle is called an area, and the area is measured in square unit. The perimeter is the distance around the circle. So the area depends on the radius. To find the area, you only need to know the radius, that's all. This pi is a constant. So the area is equals to, pi is 3.14 or 22 over 7. So I'll just put pi multiplied by r, that's 5 meters. So 5 meters all square. So the area is equals to pi times 5 meters all square will give you 25 meters square. And if you multiply 25 times pi, you get 25 pi meter square. So the area can actually be 25 pi meter square, or if you replace the value of pi with 3.14 or 22 over 7, you have the area to be 78.54 meters square to 2 decimal places. That's the area. Now to find the perimeter, the formula is 2 pi r. So it's 2 pi multiplied by r is the radius, which is 5 meters. So if you do this, you multiply 2 times 5 meters, that's 10 pi meter. And if you do not want the answer to be in terms of pi, if you want the answer to be a decimal, you replace the value of pi with 22 over 7 or 3.14 and simplify the result. Your answer will be 31.42. So this is 31.42 meters. This is how you can find the area of a circle and the perimeter of a circle. Thank you for watching, and we hope you subscribe to this channel. Bye bye.